Alrighty, so we are in video 2 at this point for the Pythagorean theorem. In this second video, we're going to talk about the converse of the Pythagorean theorem and then also this idea of Pythagorean triples. The hard part is done. The converse of the Pythagorean theorem is pretty easy, and the Pythagorean triples are even easier. So let's get into it. We're going to start with a definition. I actually don't really like this definition. It's kind of mathy. It's sort of hard to get, but I'll explain it. So, if a triangle has sides A, B, and C, and A squared plus B squared equals C squared, then it is a right triangle. Here's the gist of it. Triangles have three sides. I'm going to call this 3, this is 4, and this is 5, just randomly. If we can call these sides A, B, and C. 5 is C because it's the longest side. If these sides satisfy A squared plus B squared equals C squared, then it has to be a right triangle, no exceptions. So I do that. I plug in 4 for A squared plus 3 for B squared and 5 for C squared. I take square, square, square. 16 plus 9 equals 25. I'm going to find that 25 equals 25. That means this must be a right triangle. And it must. My picture's bad, but deliberately. I wanted to show you that the part that matters is the lengths. A 3, 4, 5 triangle is always going to be a right triangle. That's just a rule, because it satisfies Pythagorean theorem. I can ask you questions about this by flipping to the back. You'll see that I'm giving you a list of 3 sides, and you want to figure out if this makes a right triangle. So what you do, you square them all. First you identify A, B, and C. A and B. C is always my longest side. C is always longest side. Then you want to square them all out and see if they equal each other. So 3 squared plus 7 squared equals 9 squared. This is going to be 9 plus 49 equals 81. There's no way this is true, so it's not a right triangle. And that's it. I'd actually like you to try J, K, and L yourself and see if any of these other ones are a right triangle. So you're going to square them all, identify your A, your B, and your C, square them all, and then add them up and see if they form a right triangle. So you're going to find that J is yes. J is a right triangle. K is no. And L is also yes. And basically, we just squared them up and saw that that was true. Which is going to take us to the bottom of the last page, looking at Pythagorean triples. And here's the bottom line. Pythagorean triples are a set of 3 whole numbers that always form a right triangle, which is a pretty straightforward idea. In my previous example, I'm going to flip this over. I showed a 3, 4, 5 right triangle. And I knew that 3, 4, and 5 are going to form a right triangle because they're a Pythagorean triple. We look over at the back. I know if I see a right triangle with a length of the side 3 and a length of the side 4, the third side is always going to be 5. And that's going to be true because if I try 3 squared plus 4 squared equals x squared, I'm going to end up squaring everything. I got 9 plus 16 equals x squared. I have 25 equals x squared. That's going to be 5. And it's never going to be anything other than 5. So, if I see two sides, 5 and 4, I know my third side has to be 3. If I see 3 and 5, I know my other side has to be 4, and so on. The same is true for all of my Pythagorean triples. So, if I have a 5 and a 12, I know my third side is going to be 13, and so on. So we have two more Pythagorean triples. I can also give you 8, 15, and 7, 17, and then 20, 21, 29. All four of these are Pythagorean triples. Now, the other thing about Pythagorean triples is that their multiples are also Pythagorean triples. So not only is 3, 4, 5 a Pythagorean triple, but if I multiply it by 2, 6, 8, and 10 is also a Pythagorean triple. 10, 24, 26 is also a Pythagorean triple. 16, 30, 34 is also a Pythagorean triple. And 40, 42, 58 is also a Pythagorean triple. That's true for times 2, for times 3. It works for times 4, times 5, times whatever. Any multiple of a Pythagorean triple is also a Pythagorean triple. So, I'm going to leave you with filling out the rest of this table. Multiply all your triples by 3, and then all your triples by 5, and that'll be your table filled out, so you can keep in mind, whenever you're solving Pythagorean theorem, if you ever see something like an 10, 24, 26 right triangle, it's going to be a right triangle. If you're given sides 24 and 26, the missing side is always going to be 10. So, that's where I'm going to leave you today, filling out that table. As always, let me know if you have any questions, and thank you very much. This is the end of the unit. Your test is going to be coming up soon, so if you need me to help you prepare for that, please let me know. Thanks so much, and have a great day.